Welcome everyone. We're going to do Module 4, Homework 1. This is a fairly short section. So this section is about something called rationalizing the denominator. It's also about something called conjugates that we'll get to at the very end. So we'll start with rationalizing the denominator. Take a look at this expression, square root of 2 over square root of 3. There's a rule that says if you're doing a problem and your final answer has a radical in the denominator, that you're not allowed to leave it that way. You have to do something so there's no longer a radical in the denominator. The trick is you take whatever the denominator is and you multiply that both in the bottom and in the top. So that's the trick. You always take the denominator, you multiply it in the bottom and in the top. When you do it in the top, you get the square root of 6. And when you do it in the bottom, if you remember the rule that says the square root of something times the matching square root just gives you what was underneath the square root, the denominator becomes 3. And so that's the answer, the square root of 6 over 3. It's important you see what we've accomplished, though. Whenever you have a radical in the denominator, you need to rewrite it so there's no longer a radical down there. Okay, let's go to the next one. You might say, well, nothing's wrong with this. There's no radical in the denominator. The denominator is 11. Well, you're also not allowed to have a fraction inside of a radical as your final answer. So what do? Well, the first thing we're going to do is what we've seen in previous sections. We're allowed to split that up into two pieces. And then we do the same trick as before. If you remember what we did before, we take the denominator and we multiply it on both top and bottom. I recommend that you pause the video and you try to finish this one yourself and then unpause. So what you should have gotten in the denominator is 11, and in the numerator is the square root of 55, and that is our answer, the square root of 55 over 11. Again, I remind you, your goal is to not have a radical in the denominator, and we no longer have that. Okay, this one here is more complicated. I highly recommend you pause the video. You try this one to the best of your ability. Be sure you simplify your final answer and then unpause it and see how you did. Okay, let's do it. We have 2 over the square root of 18x. Same trick as before. We multiply the top and bottom by the square root of 18x. When we do that, we get 2 times the square root of 18x on the top. Nothing really changes. We're just putting the 2 next to the square root of 18x. In the denominator, though, we do the same trick as the last two problems. Since these match, the radical goes away, and you just get what was underneath the radical. Now, you might be thinking, and this would be wrong, but you might be thinking that the 18x will cancel with the 18x. It does not cancel, because one of them is inside of a radical and one of them is not. Those are two different worlds. They don't interact. But what you can do is cancel these things that are not in the radical. And so now we have the square root of 18x over 9x. We're still not done. And no, for the same reason as I mentioned before, these do not in any way cancel each other the way they stand. But what you can do at this point is you can do a factor tree with the square root of 18. I know there's an x here. I'll come back to that, but I'm ignoring that for the moment. The square root of 18, if you do a factor tree, if you remember how that works, you will get 3 square root of 2. But since there was an x on the inside, you're really going to have 3 times the square root of 2x. So that's what your numerator becomes. So this now becomes 3 square root of 2x in the numerator, 9x in the denominator. We can now cancel the 3 on the outside of the radical with the 9 that's also not in the radical, and we end up with the square root of 2x over 3x. And that is the answer to that one. Now, there is another way you could do it. There's nothing wrong with what we did, but there's another way you could do it. You could take the original expression, and you could first do the factor tree, which makes the denominator 3 times the square root of 2x. Then you do what we did before. You multiply the top and the bottom by just the radical that's in the denominator. Notice I'm not multiplying by the 3, just the radical part. When I do that, the numerator is 2 times the square root of 2x. I'm just multiplying those together. And my denominator is going to be 3 times whatever that times that is. And that's just regular 2x. The 2's cancel here. And surprise, surprise, we end up with square root of 2x over 3x. The same answer as before. So another way to do the same thing. Whichever way you prefer, go with that way. Okay, we're going to rationalize the denominator here. Why do we need to rationalize it? Because we're not allowed to have a radical in the denominator. Well, there's the easy way and the hard way. The hard way is the way we did all the other problems. The easier way is just to see that the square root of 16 is 4, the square root of 25 is 5, and there's your answer, 4/5. Nothing more you need to do. Okay, a little summary of things. A fraction is not considered simplified if there's a radical in the denominator. Similarly, a radical either is or is not considered to be simplified if there's a fraction side of it. In other words, remember the example 5/11ths, a fraction inside of a radical? That is not considered to be simplified. And we did simplify that. Okay, we're going to talk about something called a conjugate. Conjugate's about the easiest thing you will see in this course. I'm going to skip this for the moment. Maybe I'll come back to that. I don't even know if I will. Here is how you find the conjugate of something. We're going to find the conjugate of x plus 4. To find the conjugate of something, you just take the beginning of it and you write it down. You take the end of it and you write it down. And in the middle, you take whatever the operation is and you put the opposite. And the opposite of addition is subtraction. Done. The conjugate of x plus 4 is x minus 4. It just means change the sign in the middle. That's all that means. The conjugate of 5y minus 2x is 5y. Instead of minus, we put plus and then 2x. That's how you find the conjugate. So the conjugate involves taking the sign and changing to the opposite. Taking the sign and changing to the opposite. And that's what it says up above here. To find the conjugate, you just change it to the opposite operation. So that's it. Relatively short section. That's the end of Module 4, Homework 1.